Good day, everyone. Today we are dealing with tangents, especially those for your cubic graphs, but in today's example, it's going to be for quadratic. So, as you can see below, I like to use this three-column method because depending on what is provided to you, you are then able to work through these three columns in different orders in order to get to either one of the options. Now, you'll see what I mean going forward. So, also one thing that you need to make note of is for this column method, you're not always going to start in column 1 and move through all the way through to column 3. What you are actually going to do is start with what was provided to you. So if they start with the gradient, you'll start in the gradient column. If they provide you with an x or with a coordinate value, then you will start in the first column. And sometimes you may need to start in the third column and work your way through, but predominantly we start in column 1 and 2. All right. So they say here, for example, that the graph of negative 2x squared plus x has been given, okay, with a tangent with a gradient of 9. Now, you've been provided with the gradient, meaning that you will be starting in the second column. The first column is for your coordinate, second column is the gradient, and the third column is the equation of the tangent, which is usually your final answer. All right, so since they gave you your gradient, you're going to start in the second column and state that your gradient is equal to 9. But then what's also very important to highlight here is that your gradient is equal to your derivative at that point on the graph. So if my gradient is 9, and what I've just told you is that your derivative is the same as your gradient, does that not mean that the derivative at that specific x value must be equal to 9? All right. So taking that into consideration, you need to derive what was provided to you using your derivative principles. That would then leave you with negative 4x plus 1. But remember, I just told you that the derivative equals the gradient at that specific point. So I can now make my derivative equal to 9. And then we're just going to solve it like a normal equation. You're going to take that plus 1 across, which would then give you 8 equals negative 4x. And then you are going to go and divide to give you that it's going to be at x equals negative 2. But now how are you going to get the coordinates? Well, step 1 then would be to go to your coordinate column. I now have the x value for that coordinate that I am then just going to sub into the original. So where f of x, right, and that x value is going to be negative 2, all right, all you would do is sub in that negative 2 wherever you see x, all right. When you put that in your calculator, you would then get that it's negative 10, meaning that the coordinate where the gradient is 9 is going to be negative 2 and negative 10. All right. Now you've got the gradient and you've got the coordinate. So now you can go and sub both of them into your formula of y equals mx plus c to solve for c. All right. So you would sub your gradient of 9, which was given to you, as well as your coordinate that you had just solved for. Oh, there I go, missing the negative. All right. So negative 10. So let's quickly sub that in. We're going to get that negative 10 equals 9, negative 2 plus c. Then all you're going to do is simplify. So that's negative 18 plus c. Get c alone, which means that c must be equal to positive 8. Thus, the equation must be our 9x plus 8. Okay, so if you apply this method, it will just make things a lot easier because Now you have just specific columns that you need to start in. If they gave you the coordinate, you would start here, then you would move across, derive, sub in the coordinate, and so forth. But I will do another example of that, do not fear. But this is what we are going to be dealing with today. If you have any questions, please do let me know.